So building large software projects and in big teams requires a modular approach to software development. We take our application code and we break it up into libraries. We take our build logic and we extract plugins. We publish those to repositories. And then we have other projects that download those repositories and make change and use that code. It's the way we share code. It's the way we work together in big projects and big teams. But sometimes a lot of times you want to make changes to the thing that the producer and the consumer at the same time. You want to make a change to the Gradle Plug-In and the builds that use it at the same time. And that isn't always that easy. Developer tooling hasn't always made this the best experience. You know, IDEs aren't always great at this. Gradle's not always great at this. And when it comes down to it, it can be painful. And when we work in multiple repositories, developer productivity can really suffer. So my name's Daz DeBoer, and over the last 12 months or so, I've been working with a team developing a new feature with Gradle called Gradle Composite Builds. Composite Builds let us take multiple independent Gradle builds and integrate them into a single whole. And the idea is so that we can reduce some of that pain and make working with multiple repositories more seamless. So today I'm going to show you a few. I'm going to step through a few examples of modularization with where we take a monolithic application, we break it down, we extract some modules, and we use composite builds to show how this can be done more seamlessly and more easily than it has in the past. So before I go on, I'm just kind of curious, who here has actually experimented at all with composite builds? Okay, a couple. Who's using composite builds every day? Cool, okay. So this is going to be a fairly introductory talk, and it's going to be mostly coding, like not too many slides, but I'm going to start with a bit of an introduction, and hopefully there'll be a fair bit of time at the end for questions. But I want to just show some of the concepts of composite builds and how you can use them in your day-to-day development or in your experiments as well. So first I want to talk about why we would want to do this at all. You know, why don't we just stick with a giant monorepo and just have all our code in one spot? It's so easy, right? But, you know, there are real benefits to breaking things down into separate code repositories. You know, there's flexibility. Like, you don't have to decide, does that code live with that project or that project? It can actually be on its own. It can be shared between those. There's performance aspects. Do I really want to be loading that code into my IDE every single day? Do I really want to be building that code every single time? I'm not changing it. I just want a jar. I just want a binary for that thing. There's also a focus aspect. Like when you can be overwhelmed by the amount of code in your IDE. You can be overwhelmed by this massive multi-project build that you're working on. So why not just focus on those few modules that you're working on and let the others just be out of your mind, out of sight, out of mind, until you actually do need to work on them. And then why can't we make them easy to pull into your IDE and pull into your workspace when you actually do want to work on them? There's an idea of controlled ownership. Some organizations really want to, I'm the owner of this module of code. If you have everything in a monorepo, it's can be tough to sort of control who makes changes to which bits of code. And I'm not saying that's necessarily a good pattern, but if it's something you need, having separate repositories allows you to exert a bit more control. Certain gatekeepers can apply pull requests to software, and so you can control it that way. Another thing that happens is isolation of breakages. If you're in a single repository and you're not using, let's say, feature branches, one person's breakage in one module that you don't care about can ripple out and cause everyone to stop working. So there are definitely downsides to a monorepo that a multi-repo can help solve. But the monorepo is so, as I said, convenient. It's simple. You know, you have everything there at your fingertips. Everything you want to know is right there. You can refactor any part of the code base and rename that, and all the things that use it are going to be renamed automatically. IDEs do this well. Gradle does it really well. You get instant integration, instant feedback on anything you break. So the idea behind composite builds is to sort of hopefully allow us to break down that divide, allow us to use code in multiple repositories, but work on it as though it's in one repository. Allow us to refactor the multiple repositories at once. It's not perfect, it's an evolving thing, and there are other tooling issues, like the IDEs need to improve, and our source control integration needs to improve, but Gradle's taking a step in the right direction, I think, with composite builds. So what are composite builds? I said just before, it's pretty simple. We take multiple independent Gradle builds and we combine them into one composite. So a build, when I say build, I mean a build configuration, like a multi-project build or a single project build. And what we do is we take any binary dependencies that have been declared in those builds. So anything I say, I depend on group, name, version, and we find another build in that composite that produces that, we just automatically substitute. We say, okay, cool, I've got that right here, I'm going to just do it. And Gradle not only substitutes the dependency, but it wires up the right task dependencies. So it works so much like a multi-project build that I'm sure you're all familiar with. So I promised you I was going to do some coding examples, and we're already getting into it. So I have a confession. So my first thought behind this talk was, I'm going to take the Gradle build, and I'm going to use composites, and I'm going to modularize the hell out of it, and it's going to be awesome, you know? And then I realized I didn't have 3 months. Because I'm going to simplify this process because actual modularization is not that easy. There are deep entanglements in your code base, I promise you. There are assumptions you're making that are going to make it really hard to break out. So composite builds doesn't magically solve those problems, and it didn't for me either. I went, oh man. So I've had to come up with more of a flimsy example that's optimized for this demonstration, and I apologize for that, but it actually helps bring the story together. So I need you guys to imagine that there's this awesome new startup called Deep Thought. Now this company has a little app they're building to answer the ultimate question to life, the universe, and everything. So it's got obviously there's this company needs a bunch of mathematicians to do the hard number crunching, needs a bunch of linguistic experts to do the language processing, understand language and that. It has a bunch of UI people to work on the UI to make that happen. You know, it's a big organization, right? And so far they've just built they've built a monolithic application. Here it is, Deep Thought. We have 2 sub-projects, the linguistic utils that the linguists work on, and the math utils that the mathematicians work on. And then we just have this top-level project, which is a Java application that references those two projects and has a main method that prints the answer to the ultimate question of life, the universe, and everything. It's pretty good. So they've been working on this for a long time, you know, and they start to realize, the mathematicians are getting antsy. They think these incredible facilities we've built, they built a plus function. It adds 2 numbers together. Like they want to share this with the world. They want to get it out there, and you know, they want to put it up on GitHub and be the most recommended repository there. So they need to pull this out and modularize, right? So they go, okay, cool. What are we going to do? And they've heard of composite builds. And they think maybe we can do this without making it such a big jump. Maybe we can do this sort of slowly and without affecting everyone so much. So let's see what happens. We're going to turn this. So this is a regular multi-project build. I've imported into IntelliJ IDEA here. All of the stuff I'll show you today works pretty much the same in Eclipse with BuildShip. So the Gradle tooling API provides the models to the IDEs. So the Gradle tooling, so these IDEs ask Gradle what's there. So these IDEs include composite builds in that way. So what do we need to do to change math utils to make math utils an included build in a composite? The first thing we need to do is change this to be include build. So that's basically saying include means include a sub-project, include build means include another build. Pretty straightforward there. Now the next thing we have to do is we have to turn this math utils sub-project into a self-contained build. Now, as I said, I've kind of optimized this. I'm not trying to make things hard for myself. But one thing we definitely need to make this a separate Gradle build configuration is a settings file. So I'll just create a settings.gradle file, and we'll give it a root project name. It's much harder to type when you get nervous up here, but anyway. So there we go. We've got the math utils build. And let's try running. Actually, I should have run it before. Hang on, I'm gonna just go back. I forgot to show you guys how this all works. I'll delete that too. So I just want to run up the Deep Thought app just so we can see it working here. So I'm just using the IntelliJ integration in Gradle to run up the app. basically we've run you can see we're building the linguistic utils library, we're building the math utils library, those jars, we're executing the main method, and we're printing out the answer to the ultimate question. Seems to be right to me. I'm sure Hitchhiker's fans will know that too. So, what else can we do? Let's just quickly look at the dependencies of this. So, we'll look at the dependencies report for this. You can see we've got 2 project dependencies, linguistic utils and math utils. Got a transitive dependency on commons lang, but nothing too surprising there. And finally, we can run the tests for this multi-project build. And you'll see we've got the language utils test and the numbers test. These guys are using TDD. They're making sure all their code works. So that'll work. So this is kind of this is the workflow we're already working in that we're going to try to keep going when we switch to a composite build. So back up this again. Include build, as I said before. Add a settings file. And let's run that again, hey? Let's see what happens. So we've basically included it as a build and turned math utils into build. What does it say here? Problem with path math utils, a project with path math utils cannot be found. So the other thing we need to do is change a project dependency into a binary dependency. So we need to refer to this by its actual full. It's going to be a group, and it's going to be a version, because that's how we define project binary dependencies. And then we'll just go and have a look in here. So the group is there, org.deepthought, and the version is 1.0. So I'll just do that, put that in there. So let's try running up again and see how that works. And it's, for all intents and purposes, it looks exactly the same. Like the output of the console is the same, the tasks that are executed are the same. But if we have a look at the dependencies report for the new build, you can see that our binary dependency has been substituted with a project dependency on math utils. So it's just working how we thought it would. That's pretty cool. So then what else do we need to do? Let's try running the tests again. Running up the tests and, okay, so something's odd there. We're not getting our unit tests being run in the extracted build. So I'm going to come back to this a little bit later. Like there are some limitations in composite build that we can work around, but this is something we'll fix up later on. But in the meantime, like that's kind of cool. So these guys have got a separate sub-project. They can now easily put this into a separate Git repository. They can include it if they want. But the linguists are now like, well, we don't want those mathematicians screwing with our code, so we're going to make our own repository and lock it down so they can't do anything to it. So same thing, we just go in here, include the build, 3 steps. We'll change the dependency to the linguistic utils, and we'll add a settings file to the sub-project. Yeah, we don't actually have to even put anything in there. The existence of a settings file on its own tells Gradle that that's actually a separate build. So now we can try running up again. We've got pretty much looking the same. The tasks are being executed just like we expected, and the dependencies report is pretty much the same as well, except we'll see that there's the linguistic utils is also being substituted. So what we've effectively done is we've pulled out these 2 builds, but you're saying, well, it's just exactly what we had before. There's nothing's different. But what actually is different is I can go in to each of these builds independently. So I can go say I'm going to cd into the math util build, and I can publish it. So I can go Gradle publish. Now these builds already had publishing configuration in their sub-project build file, so it made it pretty easy for me to migrate. But so I'm going to publish that one. So now math utils has been published to let's have a look. It's been published to a local repository. There it is. There's our POM file and all the things. What I can do now is I can actually go in and just comment out that line, run again, and you can see what I've done is I've removed math utils from the task graph. I've removed math utils from the noise that I might see. And I also, I can also show that I've now removed math utils from the set of projects that IDEA knows about. So suddenly, IDEA indexing doesn't have to worry about all those classes in there. I, as a developer, don't have to worry about all those classes in there. Gradle, when it's running, doesn't have to worry about those things. It's just getting that stuff from that repository. That's a pretty powerful thing. So we can try removing linguistic utils again as well. And fails. We didn't have a published linguistic util. So let's try that one. Get that one published as well. Actually, no. Let's hang on for 1 sec. Let's not do that yet. We'll add them back in, and let's see if we can get it. What I really want to be able to do is publish everything. I don't want to have to CD into these builds and publish them individually. But as you saw, the running publish from the top level build doesn't trickle through to those sub builds. There's no automatic delegation of tasks from a composing build into its included builds. But it's not too hard for us to add that. So I'm just going to say what I want is my task. I'm going to create a publish all task, or publish. Let's call it publish modules. And I'm going to say depends on every included build tasks, every included builds task, publish task. So let's see if we can run that up. So hopefully I've got the syntax right for creating a task. And it looks like I did. So it's both publishing the math utils and the library and the language utils jars. So effectively what I've got now is I've got a task called publish modules in my composing build that will basically call publish on every included build. And what that means now is I can very easily go in and say, I don't want those in there at all anymore. And I can run. And I get the fastest build that I need so far, which is basically ignoring that lib, just basically treating those as external dependencies. Don't bother me with those at the moment. We can refresh our Gradle projects, and you'll see that that one's been removed as well. So I'll add those back in. Okay. So we've got these things, but we still have that issue. That issue with testing. There's something going wrong there. So let's just see. Let's have a look what happens when we run the tests now. We're running our Gradle test task, and basically it said that nothing was run. Let's have a look. So we built the math utils jar. It was up to date. We built the linguistic utils jar. It was up to date, but we didn't. I can't see let's have a look. I can't see math utils test anywhere. No, it's not. It's just not even being executed. Now this is because, for the same reason as we did with the publish, we didn't have that task delegation set up. That's pretty straightforward to fix. We fixed that for publish. I think we can probably fix that for test as well. Everyone familiar with that groovy star operator, or should I do something? We can iterate. Okay, try something else. So I don't want to make this magic, because it really isn't magic. So I'm going to do gradle.includedbuilds.each, and I'm going to say test depends on, and here we're going to say that's a build. So that's an included build, and I'm going to get the test task from that included build. So this is kind of a shorthand for iterating over all the included builds and getting the collection of things that is the result of executing that method. So let's see what happens now when we run the test task. So we're effectively trying to run the test task in each of our included builds when we run test in the top level build. Okay, so it worked, but we still didn't get any test events received. Anyone got any ideas? Anyone see anything up there that would hint what might be going wrong. I can see something weird here. See this no source. So something's odd, right? Something's weird, like I've extracted this build and it's no longer recognizing the source of the tests. So something's odd. Let's have a look. So this is one of the things that happens when we do start modularizing, right? We didn't realize that there was a dependency here and we're missing it. What I've got is, if I look at the math utils library, it's got source, test, groovy. IntelliJ tells us straight away, this is not even considered a source set. And the reason is because we haven't actually applied the groovy plugin to the included build. Now it was applied before, and I'm guessing it must have been applied by this subprojects block. So that subproject block is no longer being applied because these are now separate builds. Okay, so I guess we're going to have to apply this plugin. So let's see what happens if we do that. We'll pull that. Oops. We might as well just cut that out of there. And I'm going to put it into my math utils build file. Okay, let's see what happens now. Okay. The problem is that plugin isn't available in scope either. So where's that plugin? It's in this build source project. So we've got a build source project here that's actually, we've already done some work of modularizing our build, sort of modularizing our build logic, but now we need to turn, build source is like an implicit plugin that's always available to every build in the same multi-project. Luckily, composite builds make it easy for us to extract this into an actual real full-fledged Gradle plugin. It's actually one of probably the most powerful use cases for composite builds now, is that if you want to build a Gradle plugin, you can't do it as a sub-project. You have to do it as a separate build. So composite builds are really powerful in this case. So let's turn it into a separate build. Okay, so I'm gonna create a. You know what I'll do is IntelliJ won't let me do it, but I'm just gonna rename the build source directory to Gradle plugins. Okay, so now it's no longer a magically named, so IntelliJ kind of knows about that name and it treats it specially, but I've just moved it, right? So now we've got a Gradle plugins directory here. It's got our source for our plugin, but it doesn't have any of the other things. So what do we need to do? Step one, we need to make it a Gradle build. So we need a settings file in there. And we need a build script in there. Now, is everyone here familiar with building a Gradle plugin? Most of you? I don't want to go through, because there's a little bit of boilerplate. I don't want to type it all out and bore you with it. So I'm going to copy a file in that I created earlier it's basically using so if I go into here, I'll cd into the Gradle plugins directory, and I'm going to copy this one that I created earlier. Okay, and what this build file does a few things. You can see why I didn't want to type it out. So we're applying the Java Gradle plugin, which basically helps us to build Gradle plugins. We're also applying the Groovy plugin because I've written this plugin in Groovy, not in Java. So I don't think there is a Groovy Gradle plugin. You just combine those two together and that gives you that power. It's also got the publishing configuration set up so I can easily publish this. And then it has the actual block that lets us configure the plugin that we're generating. So we're generating a unit test plugin. There's the ID we have. And there's the type that we're going to, the implementation class. And that matches up with the implementation class we have down in here. So this unit test plugin, what does it do? Basically applies the Groovy plugin. It also adds JSON as a repository and adds a bunch of test implementation jars so that Spock works. This is kind of the sort of thing you want to pull into a bit of separate build logic. You know, like you want to be able to, you don't want to copy and paste this in every one of your builds. You want to be able to reuse that. So it's kind of cool that we're going to extract this into a plugin. We might even publish this to the portal. You know, that might be useful for someone else. Maybe a little bit more useful than our number utilities that we were publishing earlier. We'll see. So anyway, we've turned this into a build. We've added a settings.gradle file. We've added a build.gradle file. So what else do we need? Once we've turned something into a build, then we need to include it. So let's say we're going to include it. We'll include it at the start because it's earlier alphabetically. Why not? And let's see if we can make this work now. So we had the test was failing before. Let's see if it's working now. No. So it's saying that there's no property org. What's that? Okay, so it's obviously not finding that type. Now, I don't know if you hark back to what I've been talking about, it's 3 steps to making an included build. First, you've got to take the sub-project and turn it into a separate Gradle build. We've done that. You have to take the composing build and include the build. You have to say include build. The third thing you need to do is convert any project dependencies to binary dependencies. Now, it's a bit trickier with a build source plugin because the project dependency is implicit. There's nowhere that you declare I depend on the build source project. It's always there. But what we need to do is actually make it a binary dependency on this plugin. So we do that with the build script block. So we need a build script block. We need to be able to say what repository are we going to get our plugin from. So we'll just get it from the one that we've been publishing to. And we need to add a dependency, a class path dependency, on our newly published plugin. Well, and not yet published plugin, actually. So it's org.deepthought is the group. We should probably check, shouldn't we? What have we got in here? Org.deepthought 1.0, and its name is Gradle Plugins. So that's the dependency we need. That's the module, that's the version. So now we should be able to go run this up and see. A little bit nerve-wracking. You can see we're building the Gradle Plugins plugin, and sure enough, tests are being executed successfully. So what happened is Gradle went, the mathutils project, its class path needs the Gradle Plugins jar. Better go build that. Okay, cool, done. That means when the mathutils project gets configured, it can apply that plugin. Applying the plugin adds all the Spock dependencies that are required, makes the test work. So I've got the test working fine. One cool thing about this is now, instead of having to, with a build source plugin, you kind of have to reference it by class name. But now we can actually go in, we've turned this into a fully fledged plugin. We can actually reference it by ID instead. And everything looks a lot nicer when you can reference by ID. Let's make sure that's still working. And let's look at our publish modules method. Is that going to publish the Gradle plugin as well? Let's have a look. We'll just have a look at our local repository again. And we have, let's see what we've got published. Our Gradle plugins module has been published. Our linguistic utils module has been published, and our mathutils module has been published. And we've also published these plugin metadata artifacts, which are used to use the plugin DSL with your own plugin repository, which I'm not going to go into today, but that's what the Java Gradle plugin does for us. So cool, everything's been published. That means I should be able to just remove, say, those 2 included builds. I don't need to include the Gradle plugins build anymore. I should still be able to run the tests, and it still works. Another thing we could do is we can refactor that Gradle plugin and say, actually, it's not doing quite what I want. I want to do something new. Let's try, I don't know. Let's try just changing that's not a very good ID, let's say. Let's call it the unit test dash plugin. We have a naming standard here, so we're going to call it that. Try running it up. Instantly, we get feedback. mathutils is trying to use this plugin with that ID. Okay, let's go in and fix that. Unit test dash plugin. Oh. So you can see we can refactor the plugin project, and we can refactor the consumer at the same time. We can then publish those 2 things. We can commit those changes to Git, and Bob's your uncle. I'm going to undo those changes, and we'll just, so what do we need to do next? We haven't got the linguistic utils stuff working yet. Basically, the linguistic utils isn't running its tests. So basically, we just do exactly the same thing. Grab that. We'll grab all of this header from the mathutils project. I'm going to basically dump it in there. So it's now the same build script block to get the plugin and the same apply block for the plugin for the linguistic utils project. And of course, we haven't included it, but if we did, those tests would be showing up as well. Should be showing up as well. Excellent. So you can see now we have the language utils test running, the number utils test running. We've got a plugin included. We can remove it because it's already published. We can basically arbitrarily say we want to run the linguistic utils with tests only. So basically we've done the hard yards. We've done the work of refactoring that we needed to do to pull this stuff out. So now we can actually look at how we would use it. I don't have a lot of time, but I'm just going to quickly go through. So first thing I'm going to do is I'm going to actually just, because what I talked about early on was multi-repo, and you haven't seen me add anything new things to Git yet, right? So this is still just still a big mono repo with a bunch of builds in it. But what I'll do first is I'm going to just delete those. So I've got math utils. Let's assume, you can assume that I've already pushed these to a Git repository and they're ready to clone. So I'm going to I've got these, remove those sub-projects. I'm going to remove all these lines here because they're kind of nothing. And cool, we've got our deep thought running. The UI guys are happy. Look at that. This is when they run their builds. That's all they have to do. It's super fast. All the utilities they're getting from another project. Now let's say the guys go, cool. Well, I mean, you probably know that the most important part of the answer to the ultimate question of life, the universe, and everything is the question, not the answer. So these guys go, well, I think we might have got the question wrong. Like, is it really 21 plus 21? No, actually, some experts decided it's actually 40 plus 2 is the ultimate question. So let's make sure deep thought still works. Oh no, there's a bug in the thought. Okay, so we're getting 80 out. So these UI guys are like, oh man, what's going on? They think, well, I guess I'll need to pull in it's probably a problem in the numbers library, so let's pull it in. In fact, let's build a mechanism that lets us easily pull in any builds that we have. So I'm going to say, I've created a modules directory there. I'm just basically going to say, for every module, every file, every directory in the modules file directory, include it. So now we have basically a flexible way of adding and removing modules from our composite. So if I go in and go into the modules directory and just go git clone math utils, one that I published earlier. Okay, cool, I've got it. Now all I have to do is go in here, say to IntelliJ, refresh that please. And math utils are suddenly available in my build. All I had to do is clone the repo into its place, and Gradle automatically Gradle found it and told IDEA about it. So now we can actually go, all right, let's, well, we're a TDD shop, so let's make sure we can write a test first. So we're going to edit numbers test. We'll try out, let's just do this. 40 plus 2 should be 42. Seems pretty right, okay? Let's run up our tests and see what happens. Sure enough, there's definitely a bug in that method. So we can then just navigate through in IntelliJ and, yes, the old double left operator error. Okay, whoop. So just going to make that right. Let's see if our tests now pass. They do. Cool. Let's run up the application and make sure it gives us the behavior we want. Feels so much better. Okay, so what do we do now? We can just go, IDEA actually has support for committing from multiple repositories, but I'm just going to do the standard terminal way because I'm an old school guy. So I'm going to going to cd into math utils. Okay, we're going to git commit fix. Going to actually we might as well go up here and use our publish all functionality. Oh, one more thing we need to do. Because we are working in the real world here, we probably should bump the version on that math utils. Because otherwise we're going to end up with overriding an existing version. So let's call it 1.1. So I'm just going to do Gradle publish all. No, it was publish modules, wasn't it? Okay. And so now we should be able to, and then what we should do is remove the included build. So we'll go back to a clean build. So rm the math library. We should see that disappear from IDEA. Yep. And we should be able to run up. Now we're getting the wrong answer again because we haven't updated our consuming version. So the only other thing we need to do is go in here and say, let's use 1.1 of math utils. And now we've basically made a change in the producer project, in the library, and we're consuming it. We've done it all without leaving the IDE. And I think that shows kind of how powerful composite builds can be for a multi-repo. So just a quick recap on what we did every time we extracted a composite build. We replaced include with include build. We switched project dependencies to binary dependencies. We converted subprojects into a self-contained build. And we applied plugins. And basically that involves extracting any common build logic out and applying plugins and adding a settings file. And finally we referenced the tasks in included builds via the Gradle included builds collection. So what are the benefits of using composite builds here? What you can use composite builds for now are quick local experimentation, easy cross-repository refactoring, a smooth migration from monolith to what I just showed you into a multi-repo, better plugin prototyping, and now, very recently, continuous composite builds are functional. Coming soon, we're going to do a lot more stuff in parallel. We're going to be better at handling non-default publications from builds, and make it easier to reference tasks so you don't have to write those delegating tasks every time for your included builds. So does anyone have any questions? I've got about 10 minutes or so. Yeah, at the back there, sir.
So in a composite build, every root project is still flagged as root because it has a settings.gradle file now? Like if I'm a plugin writer and I'm walking projects,
Yep.
each independent build within the composite build is still marked as a root project.
That's right. You have to walk the builds. You wouldn't be able to. You can't just walk the projects. Yeah, you will. If you listen for events on those builds, you'll get the project path, and there's a new method called identity path, which shows the full path within a build as opposed within the full path within a composite build, as opposed to the path just within the build it's defined in. Yep. I was git ignoring the modules directory and checking out there.
All right. That part of the pattern seemed to be missing.
Yeah, I mean, so tools like MR and even Git submodules, I think, let you do this sort of thing. So I'm assuming that I'm not trying to cover all of those other tooling as well because it's a little bit too much to cover. But yeah, I would assume that you'd be able to work well with that pattern using MR or repo or something like that.
Otherwise, it could have been a parallel directory.
Yeah. Yeah.
So if I understand it right, it looks like the include build syntax supports essentially a file system reference to
There's definitely plans to do. I think Hans mentioned in the keynote that we wanted to support source dependency. And we see those. It's likely those are going to be implemented via composite builds. So you can maybe have a dependency on a Git URL and have Gradle manage the cloning of that as well. So yeah. There was a question on Slack that I promised to answer. So it was about the the task delegation. So you saw that I was I delegated a publish all task down to all the publish tasks. I delegated test down to all the test. There is a way to using a task rule to do that without having to define which tasks you want to be. So I just nope. So this is an example of a task rule. Basically, what a task rule does is it says, if I've been given a task that I don't recognize, see if there's a rule that will create this task for me. So what I've said here is if you create a task, if you type in anything, all publish, all test, Gradle will then create a task that depends on all of the respective tasks in all of the included builds. It's not perfect. It doesn't let you do. The problem is these are task paths, which means they don't handle multi-project included builds very well. But it's certainly a step that way, and we are going to be working on this in the future to improve. Any other questions? Yes?
So in the composite build example, did I have to use a repository to refer to the other artifacts, the other jar files?
No, as in, you could just have the binary dependency and assume that the builds are always included, and then the repositories block is not required. Yeah, so if it will, because what we do is we first substitute with project dependencies, and then if there's no external dependencies to resolve, we don't need a repositories block at all. The reason I did is because it allows us to see, you can remove this included build, which is some of the power is to be able to selectively include builds and have the other ones automatically resolve from a repository. So if there's no other questions, thanks very much for coming along.